Okay, since last meeting, I was showing the my robot with it just kind of piled up and stuck together, and I had a weight on top so it didn't fall apart. And so this time I spent the week playing with it. I'm getting down to the point where everything's bolted together. I can actually pick it up. Let's see, do this. So now it looks like this. And you can see on the top here, I was saying last time I had to build a box to hold the whole thing together. So I built this wooden box here, and it's still got then the plate is bolted on that runs out the front. So that's all one piece. And at the moment, I just have on the back, I have one of the two motors sort of stuck in. It won't work until I tear the whole thing apart. I need to take these brackets off and take this green tape out that's underneath. I was using green tape. That's how I would have marked the plastic so I could drill holes. So I just stuck one motor on just to show that's where the motor is going to go. The other thing is on the back, I replaced the, I had a piece of plastic hose here holding these two shafts together, and it wasn't strong enough. So it wouldn't hold the two pieces not parallel, concentric, whatever. It wouldn't hold them in line. So I went back and got my steel piece that I had. And originally I drilled and tapped it so I could put screws in like set screws, but they weren't working because I was just using regular screws. So I drilled clearance holes and then drilled in the shaft and tapped the shaft and put the screws into it. So that seems to be working out okay on that. So I was just taking a tour around the thing quickly here. So again, you can see there's just two boards on the side here to form the box, and then across the top there's a plate. And I got the board that runs all the way to the front. It just bolted onto that, and that's basically, this is the way the bigger robot is done also. So if you just take a tour here, let me point out here again. So the wheels have tooth pulleys screwed to the side of them, and then on the end of the motor there would be a pulley. In fact, here's one of the pulleys laying right here. If I can show this in the view, so it's just a pulley like that screws onto the end of the shaft, and there's just a short belt that goes between the motor here and the pulley here on the wheel. So I just need to get those bolted on, but I have to take the wheels off, take everything apart, put the thing on, and put it all back together. But before I do that, I want to take the green tape out. So that's what stopped me on that one. So we just take a tour around the thing here. And again, this is on a Lazy Susan bearing that I built basically for testing gyroscopes. I can put a big robot on here and turn the whole thing. And then the front here is the, looking up under here, I got the RC servo, the giant RC servo, one of these servos mounted up inside. And it's on its own. I built a frame to put that on, just a couple of pieces of angle. And then in the front, might get better or worse views of this, but in the front here, then that is connected as a angle going the other direction. That's got 3 screws holding it there, and then in the front, when we get around there, you can see there's 2 screws that on each side that hold that to the axle. So basically, the RC servo there is bolted right on the axle. So if the axle pivots up and down around this point right here, it's got that bolt stuck through there, so the axle can tilt back and forth like it does on a full-size tractor or lawn tractor. And then here's what I was talking about with the bolts. So this right here is the bracket that holds down below here. You can see the frame on the RC servo, and right here is just an angle bracket that connects that frame onto the axle. So these 2 bolts here is what holds that on. So it just makes that all one piece now. And again, here's the turning thing. I can't. I put down jar lids to keep it from rolling around on me. It's not gonna play right now. So we'll just keep moving there. So that's what the front end looks like. The axle is completely a unit with the RC servo on it, and then it just has these vertical brackets here made out of steel. There's one on the front of the axle, one on the back, that allows it to tilt. And of note here, So coming back around again, you can see the RC servo back in there, and I had to be careful. So because the RC servo would hit this board, the motor on the top of the motor would hit the board, so I had to be careful when I measured it to get that right. So anyway, that's the we're basically all the way around to where we started there. And let's see, I was thinking I could pull this off now. It's going to show up. No, not real well. So on the bottom here, here's the RC servo, and as I say, it's bolted to those those two pieces of angle to form a bracket. You can see then what's bolted onto in the front here. You can see where it's bolted on. You can see where it's bolted onto the axle here. And here's what I was talking. Here's what I was talking about. The moves. It can go up and down like this, so it can. As you drive over uneven ground, it just keeps compliance with the ground. And these things are still flopping around because I haven't done anything with those. So I need to get I need to get a plate or something screwed onto here, and just would stick out. This is real inconvenient here. So
fine.
So anyway, I need to get something screwed on, like get a plate or something bolted on here that runs back this way, and that'd be my control arm. So as I move the wheel, it does this. So then I have to have from here, I have to have some kind of like a plate sticking out, and then put a ball joint here and a ball joint on the end of this thing sticking out here, and that way that'll control the steering. And I was trying to decide, do I want to have one rod that runs all the way across, which is the way I did it on the previous robot, and then just the RC servo would just push and pulls on one side, so that the arm that goes all the way across the hold on, let me switch cameras here. So the arm that goes all the way across from one side to the other gives me my correct Ackerman angles for everything. And I didn't know if I run a control arm from one side to the center and from the other side to the center. I didn't know how well that's gonna work out. I don't know if that has to be both the same length or whatever. That's something I could experiment with. Probably no matter what I do, it will steer, but it won't be as good as it's supposed to be. So I might go back to the thing. I'll just put one control rod, steering linkage all the way across from one side to the other, and then just have the RC servo just push and pull on one side or the other to make it work. So I guess at this point, that's basically where I'm at with that. And one other thing I did was, as I pick it up, I'm thinking, boy, this is getting heavy awful fast. And I had no, I was guessing 10 to 20 pounds. So I weighed it this morning. I just stood on my bathroom scales and weighed myself, and then picked up the robot and weighed myself again. And it's about 17 and a half pounds already. I think a lot of that is those wheels in the back. They have a steel, two pieces of steel stamped. They were stamped out and then riveted together. And then it's got a big neoprene. Think of a giant O-ring made out of the same type of material, maybe a slightly harder material. And that's what those wheels are. So the wheels themselves are heavier than I'd like them to be, but that's just the way it is. So unless they're replaced with those plastic wheels like I have on the front, but it was all machined out. And as I say, I screwed the pulleys to the side of the wheels, and I have to redo all that. Or I should just find some better motors and put some of those plastic wheels right on the end of those, but I don't have any convenient to do that with. So at the moment, that's where I'm at with that stuff. So I guess that's all I got to say. You're on mute.
It looks like good progress. I mean, it's getting that physical stuff. Well, it all takes time, but the physical stuff, I don't know if you can't use hand tools, but you're trying to keep it small. I think that's a great idea, but definitely good progress. Until you turned it over and started showing that linkage, I was confused whether the servo was attached to this, basically the axle, or not, but you clarified that. And then battery, what sort of battery power are you planning?
Hold on a second. trying to open an image here, and of course it doesn't want to play. Oh man, Slack is just going out of their way. Let's see, which computer is that on? Well, anyway, here let me do this. It's not going to work well, but I'm going to do it anyway. And let me say share screen and do this one and get out of the way. Get this out of the way. So it used to be in Slack, you could actually look at something and see it, but now you can't anymore. On my Linux computer, I could right click and say open in a new tab, but I can't do it anymore. Here, I can say copy image URL. Let me try this. Copy that. Let me go back here. Let me go here. Paste that. Because it's trying harder now. So anyway, this is a picture of my original robot, and I was going to say it's just like this one, but I don't have my background turned on. Let's see how to. Oh, I'll show you in a second here. Of course I can't turn on my background because when I started screen sharing, my stuff all went away. So anyway, this on the this over here, that's too much. Oh, now I don't have the option of controlled zoom. I'm either zoomed in or not. But this is my new one down here at the bottom.
What I still see is a Slack screen print sort of thing.
Oh yeah, of course you do. Go here.
Andrew, I'm on a call, but what's up?
So this is I assume you can see it now. This is the down at the bottom is my new robot, and down at the back behind it is the my previous robot, and it's really not that much shorter. Lengthwise, it's 3 inches shorter, and widthwise, it's like 5 inches narrower, and the height is maybe if you look at this board right here, this is the that's the equivalent of this board right here. And it's a little bit shorter than that. And then I've got all this junk piled on top. So that's what makes it taller and so big right now. So if I throw a lot of this stuff, if I put all my computers and everything down inside this box, it'd be nice and short and small. So if I zoom in here, of course, nothing's going to work. So again, this is the stuff we were just looking at on the first view. You can just see it's exactly in the same condition it was yesterday, or as I was just showing it now. It's just that the whole point was to show it compared to the one in the background here. So it would be nice if I could go to Slack and get variable zoom on this, but of course Slack no longer allows me to do that. Plus, if I open it, since it had a thread, it says to put the thread out to the side. So that's just more complaints about the modern software that we were forced to use. So let me go back here. Let me stop sharing. He's back over here. Oh, I was going to say, let's see, is this going to work? Background. So as I was saying, I could go like this. Oh, it's like this one back here. So imagine the other one sitting in front of it. Now it'd just be a smaller vehicle sitting there in front of it. So choose background. None. Okay. So that's that was the point. That's the size comparison, and the weight is like 17 and a half pounds, and I have no idea how much the other one weighs because I have no way to weigh it anymore. But it definitely has a 30-pound lead acid battery in it, and it's got a 10-pound industrial LiDAR on the front. So there's 40 pounds right there, and it was fairly heavy to start with because it's got that mobility scooter transaxle in the back. It's got the big pneumatic tires like off a go-kart on the back and slightly smaller ones in the front. So it probably weighs 75 pounds, and maybe I could stand on my scales and pick that up at the same time, but it's getting awful heavy to do that. And I don't have, if I still working at Danfoss, they had this nice scale on the floor. You could just drive stuff onto it and weigh it, but I'm not there anymore, so I can't do that. So that's all I got to say on that, I guess. Oh, you were asking about batteries? Is that?
Well, I mean, yes, I was curious what you were thinking about, but if you're gonna put another 30-pound lead acid in there, that'll be fine.
I won't, because that's the whole point. I don't want it to be as heavy this time. I might just use the radio control battery packs. So it's got the either NiCad or the nickel metal hydride or even the new LiPo batteries. I might put 2 or 3 of those on there to give me my whatever voltage I need. Those will be a lot smaller and a lot lighter than putting the big lead acid batteries on there. And I may just put those on the back over the top of the motors. There's going to be room there to put something, and since I'll need to swap them out to charge them, that'll be a reasonable way. And then inside that box that I use to let me go back. Well, I was going to switch the camera, but the thing's laying on its back right now, so that won't do any good. What was I saying? Oh, so it forms a box there, and on my previous one, that box is where the lead acid battery went inside of there. But if I put the batteries on the back, I've got room inside of there if I want to go with 1 or more Raspberry Pis or a Jetson Nano or whatever I want. I could fill that full of all the electronics, and I wouldn't have to stack all that stuff on the top like I did on the previous one. So that's just more stuff I'm thinking about. And I really haven't thought too far ahead, other than I'm okay. I got these pieces, I want to bolt them together, and I put it all together with clamps. And now I've gone back and created created the box and got the whole thing bolted together, so it's actually one piece now. So now it's just a matter. I need to work on that steering and get that so it'll actually that'll turn, and then get the motors bolted on, and then I'll be the point I'm gonna have to actually do something in that point. So instead of just thinking about it and playing with it.
All of it's doing something. It all takes time.
And then Bob had said, could I how did he say that? Here's the
some sort of comparison between your builds.
yeah, I was trying to think how he worded that though. Let's see, it's on the screen. It said, wait a minute, why does that look? Oh, so I was just complaining about the way Slack works. Let me show the screen again. Do that. He's over here. Okay, now it's looking fairly decent. I guess part of the problem is when I put my cursor over it, see it turns all the stuff at the top and the bottom and blurs out part of the screen. But that right there doesn't look too bad. But see on the front, if it's got a thread attached to it, now it takes up part of the screen to show you the thread. But I can come over here and now run this in and out to show this kind of stuff. Then I have to move my cursor away, I guess, to get so it doesn't blur out half my screen. So let's see. So Bob says, any chance you could show a lineup of all your bots? Now, when I first read that, it's something I'd thought about earlier in the day that, I could get, take all my robots, put them out in the yard and put them, from largest to smallest and take a picture of that. But he might just be saying, show a picture of everything you've ever done, whether they're, lined up or not. So that I could do that. I've got a robot graveyard in my living room where I've got like 3 robots are piled up on top of each other right now. And then on top of that is a 3D, like a 3D wood carver, like a numerically controlled thing. I could take that off. So it's just the robots that take a picture of that. But that's just more work that I want to go to at the moment. So, and somewhere I've got a picture that's, I don't know where it is right offhand, but basically what I was trying to do, I was trying to test out the photographic printing at Walmart. I thought, well, what do I want to do? So I just pulled up a blank image and just started cutting and pasting pictures of my robots. So they're just all spaced around on the screen. And I just put a title that says Jeff's Robots or Jeff's Robot Evolution or something. And then I just took it over to Walmart and printed that out. So I've got like an 8x10 that shows that. So somewhere I've got that original image that shows quite a list of things that I've done. And since we're on that subject, I'll turn it over to you, but while we're doing that, I'll go look up a link that shows It's my member page on the Twin City Robotics that hadn't been updated for, I don't know, 10 or 15 years, but it's got, shows a lot of my early stuff that if people want to dig through that, you can. So with that, I'll say, I'm going to turn it over to you and I'll start I'll look for that link and then post it in the chat. Unless you have any more questions.
No, I'm good.
One other thing that comes up, each time you make a new robot, well, what are you going to put on for sensors? And I was thinking, well, if I get my lawn tractor running, I can take one of the two GPS off this robot that you can't see, take the front one off that and put on the lawn tractor. So I got an RTK GPS for that. So this one, I might take some of those older, the previous generation. I've got it's a uBlox M8T receiver. So it's single band. It's I believe it is multi-constellation, but it's a single band, so it doesn't work as well. But that one requires you have to connect that to another computer and run RTK-Lib in order to do the RTK to get it to work. But it might be worth screwing around on that and get that to work. So I would use a $75 module and like a $10 or $20 antenna, and it will give me RTK that when it's locked on and working, it works just fine. But it takes like 3 minutes for it to lock on, and it might drop out, and then takes forever for it to lock back on again. So that's something else that I could put that on. Or I could just take one of these crappy little ones like this. It's just a commercial run of the mill. This is a single band and GPS only, but it plugs right into USB. It's one of those BU 353s or something. I think that's what it is. And that way, it's going to be good within 5 to 10 feet. So then that's a good point to start checking, so if you got crappy GPS, how do you get around that? So that'd be another thing to experiment with and see what that does. So that's all I got.
Cool. My status, why is it? Previously, I needed to get my TF tree cleaned up. And then the big thing was to get move base flex to produce command velocity data. And then the other thing just to mention is creating a PNG map file for RViz and hopefully give me some. I don't know if it's going to fully work or not, but I've made some progress there. So let's see what to share first. So Move Base Flex now appears to be publishing a command velocity. I've drafted this map file and I've rebuilt another machine with the notion of trying to clone ROS Ag completely and see it. I don't know, just to see if that still works. But some of the things, this again is out on GitHub. It is that spreadsheet that I was just showing is in here under milestones. Let's see, what did I want to share? So in Slack, I posted an image of, come on. Yeah, so this was just a screenshot of, having that plan produced and having something show up on command velocity. It hasn't been tested substantially other than that, because then I said, oh, okay, well, I guess I need a map. So then I don't need a map, but I've got sort of tight quarters here in my backyard, and I thought a map might be helpful to keep me from banging into something. So back on here, there's a well, there's two files out there. I thought that one I deleted, but so just making a map, steps I went through quickly. I used Google Maps and just did a screen print, saved the screen print, and then put that in PowerPoint, and then started just drawing on it. So, I mean, this is, as you can imagine, a screenshot of the backyard. Pulled that into PowerPoint and started drawing black lines around things I don't want to bang into, and filling in shrub areas, and then just deleted the image file off of that. So I'm left with this black and white file, and then trying to figure out the origin, which is the lower left corner. Is a bit of a learning exercise for me, but yeah, there's some notes in here. So at the moment, the YAML file just looks like this, referencing that PNG file, and then the resolution was set by dividing the number of pixels of the image by the number of feet, the actual number of feet, which again is an estimate based on Google Map measuring tool. And so then here it appears here it appears in RViz as of this morning. And so the next step is to do a little bit of driving around and testing and see how accurate the map is, and pick a couple of points here and try to send it to 2D NavGoal and see what sort of data shows up. One thing I do have of concern, this is pointing east when in fact the IMU should be saying it's pointing south. So I gotta, those darn IMUs, but that's where I'm at.
Normally when you're creating the map like that, you would scale your map to match what your resolution says, as opposed to going the other direction. Because I think when you're changing that resolution on your map, that's telling the system how big your squares are. It's just that normally you decide ahead of time what you want your map resolution to be, and then try to get your image scaled to that. And I've never figured out a good way to do that, so I've never actually done that. You like you did, you said you copied Google Maps, and then you'd have to scale that up and down to get it to match, whatever it thinks it is. So that'd be that would be, I believe that would be the correct way, or the way that's the way other people would do that. So it really hadn't occurred to me to take any map and then go into your YAML file and say, oh, here's the resolution per pixel. So it hadn't even occurred to me to do that. But if it works, that's good to get started.
Yeah, I mean, there was a post or two that suggested that, so that's how I ended up doing that. But anyway, I guess we'll see. If I drive around and everything is off completely, then yeah, we'll back to the drawing board, as they say.
So it could be, one way to do that would be to go into your YAML file and say, I've got, say, 2 inches per pixel, or whatever size you want. If you're running outdoors, you might want to make it bigger than that. But pick a standard number there, and then say, okay, if I want my map to be 100 feet by 100 feet, just figure out a size of rectangle that would make that, and then basically go into your Google Maps, and then on there, if you can, let's see, Are you using the online Google Maps or using Google Earth to do this?
online.
Because you can check there to see, can you draw lines right on top of the map right there, and they just draw a rectangle that's 100, say 100 feet by 100 feet on top of the image before you cut it out, and that way, um, I think it'd be easier to scale it that way. So if you're telling it this is on the image I'm looking at, this is the extent of what I want. So then you could go and cut that out or whatever, do a crop. Once you save it, then crop that, and then if you get some fancy image editing software, you can grab the image and drag, scale it up and down to get it to fit what you want. So there's, as I say, I've never actually got around that. I did do something one time before ROS. I was figured out how to do all that with at the Robo Magellan competition in Chicago. They had it at this Maureen Valley Community College, and I went into Google Maps or Google Earth, whichever, and tiled a bunch of the images and pasted them all together. And then I was using Visual Basic at the time, where I was able to go in and say, I kind of like finding your origin. So you find a point somewhere on the ground and say, okay, this is at this latitude and longitude, and it's going to be 0, 0. And then you just figure out, measure the opposite corner of what you're looking at. And then I just, figure out scale factors to do all that. It's so basically it's the same thing ROS is doing, but I didn't have ROS in front of me to do that. And essentially what I was doing is what you ended up doing, changing the, you in a YAML file and said, well, the pixels are actually this big. And that's what I was doing with the stuff in Visual Basic that I was doing. And I got to the point where it did work and seemed to work out fairly well. But now with ROS, technically you should go into your map and set how big the pixels are, and then somehow figure out how to scale your image to fit whatever that says.
This is an interesting video of a girl who wrote a Python script to take
Can you post that link?
It's also in the instructions, but yeah.
The instructions, which instructions you're talking about?
This making a map that's in the GitHub. And she basically, you can look at the script. It's not bad. She creates her YAML file and the PPG file. Where I'm using a PNG file, just a straight image file. I guess there's another file that I don't know the exact difference between that, but yeah, it's an interesting video to watch. But again, she's starting with a predefined, in this case, blueprint of a building. So that's interesting how she did that. So anyway, that's where I'm at, trying to, if it's completely useless, then I'll just delete it and sort of hunt and peck and try to find some positions to test and drive to.
And it could be what you have will work just fine. I don't know. I just, try it out, see how it works, and let us know what comes out of that. Oh, their point was, the reason I asked why you're using, or if you're using Google Maps or using Google Earth. Google Earth has a lot more tools for doing, for doing this kind of stuff and for measuring and all that kind of stuff.
Yeah, it's been a while since I used it, but it definitely is very powerful. All that KLM stuff. And one of the things that I'm not struggling with yet, but I think what I would do around the origin, let's see if I've got it in here. This origin statement is only going to be good if I start the robot in the same place every time. So that's going to be a constraint. And so I was thinking about, if I save the latitude and longitude of the lower left corner I could calculate, and I fire up the robot and I get RTK, I'm going to get a position, then I could calculate potentially the X and Y from that original lower left corner position. But anyway, that would just be,
But
I think
isn't that what GPS ODOM is doing? You specify a origin somewhere on your property. And when you start the thing up, it takes in the latitude and longitude and says, oh, you are 10 meters by 20 meters from that origin. So it's, I think by definition, that's what it's doing. It when you start up your robot, it should know where it's at. Unless you're doing something different.
yeah, the robot. Okay, then how would you dynamically update this origin statement in the YAML file?
Why do you want to update it at all?
Well, in your understanding, what do those 2 points represent? Obviously, it's the distance from the lower left corner of the map, but to what?
Well, your map is going to have a 0, 0 somewhere. And I don't know if it's the lower left corner or the center. I think if you fire up like slam G mapping, I think it puts 0, 0 in the center of your map. So it's just a number, just a number in meters that's 0, 0 on your map. And then when you go to your GPS ODOM, you want to specify an origin. So you say, here's my latitude and longitude in the world. This is going to be my origin there. And I think that origin will be on top of the map origin. I think those will be one and the same at that point. Now, I might be wrong on that, but I'm thinking that's what that's doing. So when you start it up, wherever your vehicle is in your yard, and you turn it on, it says, "Oh, I'm this XY from the specified origin that I specified as lat lon in your GPS ODOM software."
Then I don't understand the origin statement yet.
When you say origin statement, which origin statement are you? What are you talking about here? Is that something in the mapping, or is that something in the GPS ODOM, or something else you're talking about?
There's a YAML file that is referenced in
The one that goes with the map. So you've got an image and you got the YAML file. Is that what you're talking about? That pair?
Yeah, in ROS Ag, there's a farm.yaml file. It pulls up the image and it provides an origin. And this is an offset from the lower left corner to something. I thought the to something was the robot. And you said no, it's
You just had that
something
file
the
pulled up.
world.
You said the file pulled up a second ago. Could you put that back up? I don't know if it's in your documentation or you had the file, but you were showing. I think you when you said you're changing the resolution in that file. Can you pull that file back up?
Yeah, this is it.
I can't see anything.
Oh, I'm sorry, I'm not sharing. There's a good reason. So this is the original ROS Ag farm.yaml file. And that resolution was set at 0.1 based on the number of pixels. That's, a 500-foot image that they created. And there's this origin statement.
So I assume what that's doing is you've got, say, a rectangular image that's your PNG file. And it's going to be so many pixels by so many pixels. And where the 0, 0 is on that, because you've got number of pixels to represent a position, and then this is transferring that to meters. So it's probably saying origin. You might want to go into oh, that's only 3. I thought that was 4 fields there, so I thought it was like an X and Y and then 2 other things, but it's not. So Did you draw that red line or somebody else draw that on there?
This is a post in ROS Answers
Okay.
that basically just says it's the lower left pixel. I mean, here's the description, and according to this post from the ROS Wiki, the 2D pose of the lower left pixel is counterclock rotation, but they don't flip and say to what. Origin, the 2D pose of the lower left pixel in the map with yaw as counterclockwise. Many parts of the system currently ignore yaw. And so my potentially erroneous belief is it's the offset from the tractor to the lower left pixel in the map.
Well, forget about the tractor for the moment. It has to do with your map. So it's a point on the map based on the lower left-hand corner. So you're going to set a fixed point somewhere on your map, and you're going to call that 0, 0 is what you're trying to do there. So regardless of, this is all done without the tractor. You've got an image, and the image represents a map, and then you have to convert between pixels and distance. So it's just a matter of saying somewhere on your map, we're going to call that 0, 0 as far as in meters, X and Y, that's going to be our 0, 0 point. So they're saying go to the, starting in the lower left-hand corner, that's the offset in meters from that 0, 0 point in pixels. So you're just matching the pixels and meters together is what you're doing there. So for instance, if you want your origin to be in the center of your map, then you would say, here's the XY distance to the lower left-hand corner in, you know how many pixels it is because you know how wide the image is, and you know how tall the image is. So that is the number in pixels. And then the lower left-hand corner, if we call that 0, 0 pixels, and you just want to know what's the distance in meters from the corner of your map to wherever your origin point on the map is going to be. So if you're going to have, let's say you're going to put the map you created, if you go to the lower left-hand corner of your image and say that's the reference point, that's going to be my latitude and longitude, and that's going to be the 0, 0 in meters, then you want to put all that stuff on top of each other. So if you've got something that's, I don't know, 1,000 pixels wide and 1,000 pixels high, and you want your origin on your map, you want your a known origin you can see from a satellite, say, okay, that's the point I want to be on my image of the lower left-hand corner. You just want to match all that stuff together.
And I think what I have seen a number of people doing, including the construct videos, is once they when they start up RViz, they will go in and they'll orient. And I think I'm trying to use the origin to go ahead and orient the map and the tractor together, as opposed to just saying, what's the middle of the map? Yeah, I mean, it may be incorrect, but I'm trying to avoid having to use the 2D pose estimate to orient the map and the tractor. Does that make sense?
What you're saying makes sense, that the way you understand it is that's the way you think it should work. But it's really just a matter of, you've got an image and you got you just want to slide that image around on the face of the earth until the two line up, is all you're trying to do there. So it has nothing to do with the the pose estimate or anything else. You just want to get, first of all, you just want to get your map set up. So if you click somewhere on the map, it says, oh, that's this latitude and longitude. And the reason it knows that is because you have taken your image from Google Maps and you want to slide that around until it lines up with some point that's latitude and longitude. That is going to be the origin of your map, I believe. That's what you're doing by changing those values. You're either sliding the map left and right, you're sliding the map up and down until a point on your map that you can see is going to line up with a physical spot in your yard. And that's why when I was thinking about my stuff, I got out in front, I've got an intersection of two sidewalks that's at the corner of the block, and I can go to Google Maps and look at that. I can physically see that, you know, right on the picture, and then I can click on that and say, tell me that latitude and longitude, and it gives me those numbers. So basically, if I just would copy the Google Maps stuff and then go in and say, I want that point on my image to be this latitude and longitude, which is also going to be my 0, 0 point. So basically, just by changing those numbers, I'm sliding the image left and right or up and down until the point you can see. Like for instance, on that image you're showing right there, where would you, how are you trying to align that to the world?
Currently, the way I'm using the origin statement is the tractor is physically here. And that means it's 25 meters this way and 12 meters this way, more or less.
That way from what?
The lower left corner, the origin.
But how do you know where that is on the face of the earth? Can you see, if you go back to your original, your Google Maps image, is there something on the ground right there that you can see from the satellite?
Yes, this corner represents, that corner represents the corner of the entrance to the garage. So it's down this way and over that way. So that's how I selected.
So my thought is from the lower left corner of your image to that point that you just said right there on your garage, that's what you want to put in. That I believe that's what your origin statement is for. It's just going to line up the map to the world. Has nothing to do with your tractor. You know, you're getting way ahead here. So, well, but you're going to get your position your tractor. No, you just want to say you want that point because you want to know the latitude and longitude of that point on your garage. And so what you want to do is just slide the image back and forth until the latitude and longitude and that point line up. And then once you fire up GPS ODOM, it's going to say, oh, well, I'm getting this latitude and longitude. Therefore, you are at some point on the map. So you're not, I don't think you have to go in and specify the location each time. And now keep in mind, another thing is, because most of the stuff you look at, they're not saying we've got an absolute position from GPS coming in. They got all this other stuff they're merging together, and
they're guessing.
And they're saying, well, we got crappy GPS, blah, blah, blah. No, you've got an accurate position on the face of the earth. You know, when you start up, you know where your vehicle is. It's at this latitude and longitude. And if you move a little bit, it says I'm pointed this direction. So it knows where it's at. So you just have to say, then GPS ODOM says, it takes that latitude and longitude and says, oh, I'm this XY distance from the origin. And then the origin, see, I think there are probably two different origins going on there. The origin in the map has nothing to do with the origin in GPS ODOM. But so in GPS ODOM, you can slide that around, put it anywhere on the map that you want. It's just that the origin in the map statement, in the image and the map YAML, that's just lining up your image with your location on the face of the earth. So yeah, I think you got two different things going on there. And the fact that everybody else says, oh, when we start up, we'll do all this to set our origin. Well, I don't think you have to do it. The way you're doing it right now with GPS, you say you got an absolute location coming in. I don't think you have to specify that up front. As soon as you turn it on, it says, I am here. and it knows where you're at.
Do you know RViz well enough to be able to tell me how do if I want to know how can I find 00 on this map in RViz? Do you have any idea? I mean, here's an X and Y coordinate. It's the and I'm sure if I Google it, I can figure it out. I thought you might just know off the top of your head.
I don't know in our viz. I don't know how you measure stuff or know where that's at. I think they're just assuming ahead of time you know where your 00 point is, which if the lower left hand corner is 00.
That's okay. I'll keep searching.
I don't know right hand, but I think you are talking about three different things here. Number one, you've got the map, which consists of an image and a YAML file, and in there, I believe the origin is saying from the corner of the map in XY meters, the corner of the map is 0. You know, on the image is 00. So you're going to pick somewhere out in your image, and that's where you're going to tell the world is my 00 location. So you could pick anywhere on that. If you want it to be the corner of your garage, then I would say measure from, figure out, go back to your graphics program where you can measure in, pixels across. So pull that up in your program and figure out what's the number of XY pixels to the corner of your garage. Now, the other thing is they're saying that they're actually attempting to convert meters to, I guess that's all they're doing. They're converting meters to pixels is what they're doing at that point. And that's why in your map statement, you're setting that resolution. Well, that's saying each pixel is this width in meters. Mm-hmm. So basically that's what the map is doing. It's saying that somewhere on here, we're going to declare a 00 for the world that's a certain offset from the lower left-hand corner of the image. So I think what you want to do is you want to go out and pull up your graphics program, pull up and look at it and say, put your cursor on the corner of your garage that you're saying is your reference point, and then just figure out how many pixels up and how many pixels over is that number. And I think that's the, let's see, are they? So you need to know how many pixels it is, and you need to know how many meters that is, I think. And that's what that origin statement is telling you. So it's saying, what's the distance from the lower left-hand corner to that corner of your garage? And then I think that will then become, in ROS terms, 00 will be on the corner of your garage. Okay. So that's one thing you have to do is get the map set up that aligns your image to the XY coordinate system. And then in GPS ODOM, it says what's the origin, and that's where you just go out somewhere in your yard and say, I want to have, wherever. One thing you could do is, that's actually, I believe that origin is actually, you tell it the location of your GPS receiver, the way that program's written. So wherever your GPS receiver is, that you're gonna punch that in, and that will become your 00 location. So if is your receiver at the corner of your garage right there, or is that out in the yard somewhere? Or?
When you say receiver, are you talking about
your base station
on the tractor, or
give me a second here.
Or the RTK correct? Where the RTK corrections are coming from?
No, I'm wrong about that. It has nothing to do with your receiver location. You just want to pick somewhere in the yard, and if it is going to be that corner of the garage right there, then you put in that latitude and longitude, and that will become 00. Do you want that point to be 00, or do you want somewhere else?
It's a lot. I mean, it's it is a reference point. It would be fine as a reference point.
Because as far as I know, you can put the reference point anywhere you want. But again, it's good to have it so it's visible. If you can see it on Google Maps and say from that location, like you had that image, and we could see your driveway there and see the corner of your house. As long as you can see that, that should work okay. It's just that. So, are you only going to operate in the backyard? Or are you going to go
I'm
below that?
I'm just testing in the backyard for the moment.
Well, the point is, if you put that corner right there of the garage we're talking about, make that 0, 0. If you drive out in the driveway, you're going to get negative numbers. If you drive to the left out that driveway or drive in your front yard, those are going to be negative numbers. So just keep in mind. So that's another reason why you could put your GPS ODOM reference at the corner of your map down in the lower left-hand corner. So then everything will be positive numbers as you drive around. So so in GPS ODOM, I think you're just picking a random point that you can see and saying, we're going to call that 0, 0. So then I think GPS ODOM is then converting whatever the incoming RTK is from your vehicle, and it runs it through and says, oh, this is my distance from whatever arbitrary origin I specified. So if you specify the corner of your garage there as in the latitude and longitude of that in GPS ODOM, then that becomes 0, 0. So anywhere you drive around, it's going to tell you the distance from that in meters, X and Y meters offset from that, I believe.
This is, I'm still sharing, right? So
Yeah.
This corner of the concrete, I mean, if I chose that, then everything would be a positive X and a positive Y. But if I set the origin, which is the distance from this corner to that, and I fire up RViz, the tractor's going to be in a very odd place on the map.
No, you're assuming that origin is origin. We could say map origin to deal with the map and lining up the image, and then call the vehicle location origin is a different origin.
Well,
which are not, they're not the same. They're not the same number.
I mean, do you have a, I mean, you can turn off recording if you want, but do you have a minute to work through this for a second? Because I'll show you what I'm referring to. This is
Do you want this recorded?
no, you can turn off recording for a minute.
I'll put it on pause.
So with Jeff's help, this happens to be a graphic of my backyard or side yard, and I'm choosing to home in on that edge of the concrete. And the reason being is if I'm primarily working in the backyard, then the X and Y's will be positive from that point, and it'll just make life a little bit easier. So what we've done using Google is we've estimated that that point is close to 16 meters in an X direction, well, negative X direction, and 0.15 meters to include in the origin statement for the YAML file. And then there's another change that's required to take that GPS point of the edge of that concrete and put it in the GPS odom.py program, because that is, again, the offset, or where it uses that to calculate the offset. So at the moment, that gives us an RViz position of the tractor about here, which is just about 4 or 5 meters south of where I think it actually is. But I think part of that is because my correction base station is sitting here pretty close to the house, and you saw that jump. It shouldn't do that. There's some deflection going on, and when I check over here on the status, it shows that this isn't rotating. So for a couple of minutes or a couple seconds, it spit out, hey, I got a bad GPS sentence. So anyway, that's helpful to know that you got to link together in order to visualize and get the tractor to show up on this map. Pick a point, put that in the origin statement, use that same point in the GPS ODOM Pi programs so it calculates the offset.
The next time that jumps, look to see where it's jumping on there, because it's probably going to be putting out a location of 0, 0. So that might give you an indication when it jumps back there. Look at that little grid right there and figure out on that grid where it's moving to. I suppose it's not going to do it now that we're looking for it to do that, but so right now, the GPS is saying I'm this far from what we specified as the GPS origin in GPS ODOM. And then when you get a bad reading, it just automatically slams in 0, 0. So that's going to tell you where it thinks the 0, 0 before any calculations are going on, which I think is the number you want to lock onto your map. So let me go through my interpretation here. As we talked about this, I think you create a map, which is a image file, and you have a YAML file. And so you just take a map of whatever size you want, and you can either scale the map to what the resolution says in the YAML file, or Al went the opposite direction. He took an image and went and changed the resolution in his YAML file to get the two to line up. And then I believe that origin statement in that YAML file, in the map YAML file, is basically just sliding the image around. So you're trying to lock the pixels onto a distance. So that's what that's doing. It's saying we've got an image of the world, and we just want to move that back and forth, and the resolution scales it. So you're setting the scaling, and then moving it back and forth or up and down until you get it so the points line up. So I think basically that statement of the map is converting meters to the pixels that you're displaying. Then the second step is, since Al is using GPS only, and he's using the GPS ODOM program, it will subscribe to latitude and longitude and compare it to the GPS origin that's in that same file. So you just pick an arbitrary point in your yard or in your field or wherever you happen to be, and you take that latitude and longitude and type into the program. And then as the numbers come in, it then returns a offset in meters from that. So if you're out in the yard or in your field driving around, it subtracts off the latitude and longitude and says you are X number of meters and Y number of meters from that point that you specified. So as you drive around, that should tell you where you are from there. And then the third point was, as he was pointing out earlier, a lot of the programs will say, well, you need to set your initial position. But since he's taking GPS only, and GPS is an absolute value, as soon as you start it up, it says, this is the latitude and longitude where you are, and it passes that through GPS ODOM. So it knows, just since GPS is absolute, as soon as the number comes in, it knows where you are from your offset in the yard, or from your origin in the yard. Now, the reason why other people are going to all these great lengths to say set your initial position is because they're going through the whole path of trying to fuse odometry, or wheel odometry, and IMU and GPS and any other thing they got. They're fusing all that together, and there you do need to have a reference to say, well, yeah, that's great, but where are we initially? And you have to go tell it that. But when you're using GPS only, as soon as it comes in, it says you are here, and it just uses that number, so you don't have to update any of that, I don't think. So that's the three different things that are involved here.
Awesome. Jeff, thank you very much for your help. I would have struggled with that, but you pushed me through.
You're probably still going to struggle with it because it's still not really clear to me exactly how those different pieces go together. But I think I think we've talked through it enough I think we got a close enough description of how that goes.
Awesome. I think we can turn off recording.
Okay.